Okay, we started our recording a little late, so we're starting here on objective 3. There is an error in the notes, so where it says y equals 2.5x, yours says y equals 2x. That should say 2.5, so make sure that you change that. So the first thing we're going to do is, we already have an equation. We're going to make a table based on that equation. So if we purchase one drink, it costs $2.50. If we purchase 2 drinks, when we multiply 2 times $2.50, we get $5. If we purchase 3 drinks, Katie, how much is that going to cost? What's that? If we purchase 3 drinks, $2.50 each, that would be a little high. $7.50. Okay, so $7.50. If we purchase 4 drinks, Adam, how much would that be? $10. Good. And if we purchase 5 drinks, Gretchen, how much would that be?
$12.50.
Good. $12.50. So we've completed our table using the equation, or you may have just gone up by $2.50 each time, since the number of drinks goes up by 1 each time. Now we're going to graph this. So first we're going to do our x-axis. Our first ordered pair is going to be 1, 2.5. So we're going to go over to 1, up to 2.5. 3 is going to be in the middle, so 2.5 is going to be maybe, it doesn't want to write. There we go. Maybe right about there. Not quite halfway up, like 1/4 of the way up. Okay, our next ordered pair is going to be 2, 5. So we're going to go over 2 and up 5. 5 is going to be right here in the middle of 5 and 6. Our next ordered pair is 3, 7.5. That's going to be 1/4 of the way up here. No, it's not. It's going to be more than that. 7 would be halfway. So we're going to go 3/4 of the way. There we go. And then we have 4, 10. And 5, 12.50. 13 would be halfway, so we're going to go about 1/4 of the way. Okay, that's what our graph looks like. Now, should I connect the dots on this graph? Okay, I saw one person nodding yes. I have Gretchen saying no. Let me, here's some rationale for both ways. First, why do you think you should connect the dots?
Actually, no.
You think you should now. Okay, why? Anyone want to volunteer why we should connect the dots? Go ahead, Athena.
Because it's like going up how many things you're buying. It's not like you're buying this much and then this much. That's just how much it is.
Okay, well let's see what happened if we did draw a line. Okay, so if we drew a line here, which I'm not going to do right now, if I drew a line, then I could have amounts in between, like I could have 1.5, and it looks like it would be maybe around 4. Would that be possible?
No.
Why?
Because you can't buy that.
You can't buy a half of a drink. So this is what's called discrete data. There are 2 types of data, discrete and continuous. Discrete data is stuff where we can't have the in-between values. You can't buy half of a drink. You can only buy whole numbers, so we don't connect the dots in cases like that. Okay, any questions about this? Okay, let's look at the next example. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So first, we're going to write an equation, or we could start with a table. In this case, it might be easier to start with the table. I'm going to use Carrie's age as my independent variable, so I'm going to put Carrie's age over here, and I'm going to put Kim's age over here. Okay, it says that Kim was born 2 years before Carrie. So when Carrie was born, how old was Kim? Zane? 2. So Carrie is 0 when Kim is 2. And that's why I used Carrie as the independent variable, because Carrie didn't exist when Kim was born, so we're going to use Carrie as the independent. Okay, when Carrie was 1, Kim then would be 2 years older, so she would be 3. When Carrie is 2, Kim would be 4. When Carrie was 3, Kim would be 5. When Carrie is 4, Kim would be 6. How can we express that in an equation? If Carrie is the x and Kim is the y, if we were to write an equation, y equals, what would we put on the other side? Volunteer for this one. Gabby?
X plus 2.
Good, x plus 2. Whatever Kim's age, or whatever Carrie's age is, we add 2 years to it to get Kim's age. Okay, now I'm going to title my graph Carrie's and Kim's ages. So your graphs should always have a title. And then you need to label each axis. So I put Carrie's age as my independent, so I'm going to put it down here. And then Kim's age is my dependent variable. So now I'm just going to create ordered pairs from my table. I'm not going to write them all down, I'll just write the first one down. So when Carrie is 0, Kim is 2. When Carrie is 1, Kim is 3. You know, it would really help if I were to label my graph too. Let me do that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'll go up to 8 there. It's important when you label your graph that you use, just like when you're making a number line, that you use the same increment, same time increment between numbers. So you could label your graph by 5s or by 10s or by whatever's convenient for what you're doing. In this case, we're just going to go with 1s. Okay, 2 goes with 4. Next ordered pair is 3, 5. Next ordered pair is 4, 6. Could I draw a line to connect this data? Lacey, you were nodding. Why?
Because you can have 5 and 7.
Yeah, you can have amounts in between ages, technically. Usually when you say, how old are you? You just say, oh, I'm 13. You don't usually say.
No, I say
But when
13.
kids are little, you know, you go by months. And some people really calculate it out. So technically we could have a straight line on this graph. And that would allow us to predict future ages as well, just by looking at the graph. So this is actually a good thing to do, to draw a line. Okay, let's see. We have one more thing that we're going to do, and we'll probably do this as a warm-up in tomorrow's class. I have a matching activity, but since we started class late, we'll do this tomorrow. So tomorrow as a warm-up, I'm going to give you pictures of graphs, equations, and tables, and you will be matching them. So let's look at how we would do this. First, let's start with graph number 1. Which equation would fit graph number 1? Volunteer on this when you figure it out. Okay, so we have 2 equations listed there. One goes with graph 1, one goes with graph 2. Which equation goes with graph 1? Gabby? Y equals 3x. Okay, so equation 1 goes with graph 1. How did you know that that equation matched that graph?
I found the line going up intersected with the other lines on here and divided it by 3.
Okay, so you found, for example, maybe this point of intersection and you divided it by 3. Okay, that was a good way to do it. Good. And then if you did that at this point where it crosses, 6 divided by 3 would give you 2. Another way you can do it is just substitute values in for x. So you could think, okay, if x were 0, 3 times 0 is 0, so y would be 0. So it works for that one. If x were 2, y would have to be 6, and that point does appear on that graph. So that would be correct. Okay, which table goes with that graph? Gretchen? The second table, good, because the second table fits the equation and it fits the graph, so table 2. And then you would fill in this with graph 2 goes with equation 2, and they go with table 1. Okay, your assignment is fairly short. It's on page 64 in your textbook. We're going backwards a little bit just to pick up this one exercise, and then we'll be moving forward again, resuming where we were in chapter 4. So you only have, let's see, 5 problems to do. They require you to write an equation, draw a table, make a graph.